learners, welcome back. In this video, we are going to discuss geometric sequence. What is geometric sequence? We did arithmetic sequence in the previous video, where arithmetic sequence you can see that the same number is adding to one term, you will get the another one, isn't it? Each term is added by the same number to get the following or the next term. So there we are adding the same number. We call it common difference, right? Now here, instead of adding, we are multiplying. Okay, all right. I will show you in an example of arithmetic sequence. Then after that, we can go to geometry sequence. With the help of that arithmetic sequence, I can explain geometry sequence. I think things are going to be very easy. Let me write an arithmetic sequence. First term is actually what I'm doing here is to find the general term of geometry sequence. But let me start with the arithmetic sequence that you know already. Those who visited my previous video, I think you know now what is arithmetic sequence, isn't it? Okay, that is first term is 2. Just an example, I will show you that one. 2, second term 5, third term 8, fourth term 11, etc. First term T1, T2, T3, T4. Okay, actually we are refreshing what is arithmetic sequence. Here we know first term 2 and we call it small letter a. And this is arithmetic sequence because common difference 5 minus 2 is 3, 8 minus 5 is 3, and 11 minus 8 also 3. So you all agree that this arithmetic sequence, because this 3, how do you get this 3? This 3 is what? Common difference, isn't it? D is same as D, because now in grade 12 common difference we call it small letter D, common difference. Then how do you get that one? Second term, if you take any two consecutive numbers in that sequence, second term minus first term, okay, that is 5 minus 2. That's how we got 3, isn't it? Now let me show you how to find general term. You already know that. What is the formula? Tn is equal to a plus n minus 1 d. The reason why I'm doing this again, because it's very important. So a is the first term. Remember, when you go to geometric sequence, there also we are using a. That a is the first term there also. So T and A is equal. Here what is A? A is 2, isn't it? And 2 plus 3 will give you 5. 5 plus 3 will give you 8. 8 plus 3 will give you 11. That's how it is. So if you get first term and common difference, you can generate that sequence. By adding 3 to each term, you will get the next term, isn't it? So the important item here is A and D. Okay, then same way, two items are there in geometry sequence. They are very important. I will tell you that. Of course, A is the first one. The next one I will tell you later. Tn, A is 2 here plus n minus 1 times D is 3. Isn't it? So it's going to be 2 plus 3n minus 3. This 3 has to multiply. Open the bracket with 3. 3n minus 3. Now simplify. The one with variable is 3n. Just write it first. Then 2 minus 3 minus 1. So this is Tn. Isn't it? Remember, the one that I showed you is arithmetic sequence. Now coming to geometry sequence. Here arithmetic sequence, the common difference is there. But when it comes to geometric sequence, there is no common difference. There is a common ratio. And here we are adding with the common difference. There you have to multiply with the common ratio. Okay. So let me show you another example starting with the 2, that is T1. T2, T3, T4. Here I am using 2 as the first term, but common ratio, the number that I am multiplying here is 3. So 2 times 3, what is the next term? It is going to be 6. 6 times 3 is going to be 18. Did you see that I am multiplying with the same number? Arithmetic, I'm adding with the same number. That is why I started with the arithmetic sequence. So 18 times 3 is 54. Guys, this pattern is known as what? Geometric sequence. Okay, so here the common ratio 6 divided by 2, you will get 3. Then 18, if you take any two consecutive terms, second term divided by first term. In the previous arithmetic sequence, we were subtracting second term minus first term. Here, when it comes to geometric sequence, you have to do what? Divide. 18 divided by 6 is going to be 3. 54 divided by 18 is 3. Did you see that one? I got a 3, but what did I do here? The process is division, right? So here 3, I got it how? Second term divided by first term. Okay, here we are subtracting, but here we are dividing. That is the difference. Guys, please try to understand. And we are using, here I used a small letter D, and here I am using small letter R. Common ratio is 3. Is it clear? And first term is 2 here, same like the previous one, but here, yes, of course, we are using A is equal to 2. Okay, now I will show you how to generate the formula for the general term. Okay, let me start. Already I did the formula derivation for Tn in the first, in my first video for arithmetic sequence. Okay, here I will show you the how to find a Tn formula for geometric sequence. Okay, the methods are almost same. I will show you that. T1 is the first term and you are using A, same like arithmetic pattern or arithmetic sequence. Guys, this sequence sometimes they call progression, but both are same. Progression and a sequence, they are same. So don't get confused when you see progression there, which is same as sequence. T1 is equal to A. Then how do you get to T2? First term multiply with the common ratio. Isn't it like a 2 times 3? So what is first term? A, and multiply with the R. So it's going to be AR. That is our T2. Then T3, how do you get? Second term, that is AR, multiply by common ratio again. That is 6 times 3. So which is going to be AR square. What is T4? T4 is same as whatever is T3 multiplied by R, which is going to be AR square times R, which is going to be AR cube. All right, I think now you can see the connection. If here the number 2 means here what? 2 minus 1, that is going to be 1, isn't it? Here it is 3 means this 2 is what? 3 minus 1, isn't it? If this one 4 means here it is 3, that 3 we can write it 4 minus 1, isn't it? All right, so what is the general term? Tn is equal to AR to the power n minus 1. This is the formula and it is very important. Tn is equal to AR to the power n minus 1. Is it clear? All right. Now we can do some examples. Example number 1. Determine fourth and seventh term of the geometry sequence 3, 15 and 75. So it is already given that it is a geometry sequence. So just find out, use the formula and find what is T4 and T7, fourth term, that is T4. What is the formula for T4? T4 is equal to AR to the power 4 minus 1, that is 3. Isn't it? Okay, so we are finding what is A here. A is equal to first term, that is 3. Then what is R? Second, that is 15 divided by 3, which is going to be what? 5. Isn't it? Okay, so we got A and R. Those are the important one. If you know A and R, you can find any term. So T4 is equal to 3. Just substitute 3 times A become 3, R become 5. 5 to the power 3. When you do this one in the calculator, you will get 375. So this is how we do it. It's very simple. Similarly, you can find T7. T7, what is the formula? AR to the power 7 minus 1. What is that? 6. That is a is 3 times r is 5 to the power 6. You can use it in the calculator. It will give you the answer 46,875. 46,875. Example number 2. Determine the first three terms of the geometric sequence of which the seventh term is 192 and the second term is 6. Now, very same type of question. We did it in arithmetic sequence, and there we use solving simultaneously method. Here also we are using, but I think elimination method is easier than solving substitution method. I will show you elimination method to find that those terms, first three terms. Okay, so what is given? Seventh term, so we can just write it t7 is equal to 192. Then second term, that is t2 is equal to 6. All right, so we need to know a and r, so you have to bring that one. So you have to use the formula. What is t7? This t7 and t2, you have to replace it. What is t7? A r to the power 7 minus 1, that is 6, is equal to 192, isn't it? Then next one, t2. How do you write t2? A r to the power 2 minus 1, that is 1, is equal to 6. Okay, now what we are going to do, we got two equations. This is the first equation and this one is the second equation. Okay, so now look at what we are doing here is just dividing these two equations. Remember, when you divide it, the bigger one, that is here 7 is bigger than 2 on the top, the way I am writing. So just divide it. Things are going to be easy if you do like that when you divide it. So when you divide it, what will happen? See, eliminating a cancel. R to the power 6 divided by r to the power 1 is what? R to the power 6. You are using the rule of exponent. 6, we are subtracting the power because bases are same. You know that this rule, okay? The exponents, the rule of exponent. When you divide with the same base, you have to subtract the power. 6 minus 1 is equal to 192 divided by 6 will give you what is going to be 32. 32. So we got it. That is r to the power 6 minus 1 is 5 is equal to 32. Therefore, r is equal to fifth root of 32 is going to be what? It's 2. 5 when you send the other side is going to be fifth root. Fifth root of 32. Or 32 we can write what? 2 to the power 5. So we can even use the comparison method to find the value of r. So we got it r. Now we can substitute r either here or here to find a. I'm using the simplest one, that is a r is equal to 6. That is a times r, we got it already, that is 2 is equal to 6. Therefore a is equal to 6 divided by 2, answer is 3. Is it clear? So we got first term is 3 and common ratio is r. Can you find first three terms? We can find out very easily. First term is 3. Second term, how do you get it? First terms times common ratio, 3 times 2, that is going to be 6. Then 6 times 2 is going to be 12. So common ratio, if you have, just to multiply each term, you will get the next term. Is it clear now? So we got it. That's how we can find the first three terms of geometric pattern. So guys, don't forget the important things are a and r. Here I used the elimination method, and I think that is quite easy to do this question. All right, let's go to the next example. All right, now coming to example number 3. Which term of the geometric sequence 3, 6, 12 is equal to 192? In fact, the very same pattern we got it in the previous example, isn't it? So the things are very easy. So very same type of question we did it in arithmetic pattern or linear pattern, isn't it? Which term is equal to 192? So how do you start this one? This 192 is what? Is one of the terms. So you have to, we don't know which term is that. So what are you going to write? Let Tn be 192. and solve and find the value of n. We are done. So what is Tn by formula? A r to the power n minus 1 is equal to 192. Is it clear? Now what is A? A is first term, that is 3. And what is R? 6 divided by 3, that is 2 to the power n minus 1 is equal to 192. Now we can find out easily the value of n, that is 2 to the power n minus 1. Send 3 other side. It's going to be 192 divided by 3, which is going to be 2 to the power n minus 1 is equal to 192 divided by 3 is 64. That is 2 to the power n minus 1. How do you find this? You are solving an exponential equation, isn't it? So just use comparison method because we haven't started logarithm. Okay, once we start logarithm, we can use log function to get it very easily. So here, since we don't know log function, just use comparison. 64 we can write 2 to the power 6. Isn't it? See, the bases are same. So the powers are, that is n minus 1 is equal to 6. That is n is equal to 6 plus 1. So the answer is 7. Which means 7th term T7 is equal to 192. You see that one? So this is how we are finding the answer to this type of questions. Okay. Alright guys, now coming to the homework section of this video. Please pause this video and write it down, these questions. Those who understood those examples that I did it in this video, these questions are very simple. Okay, in my next video I'm going to do few more questions in geometric sequence or progression. Then after that we can go to some formula.